Hi, we are going to do some problems with z-scores and how we find the right proportion or probability. So we're going to do problems involving IQ because IQ tends to be a easy to work with variable. So the mean for IQ is always 100. Hold on, I've got a weird line there. The mean is always 100, and the standard deviation is always 15. So those scores have been normed so that they always fit with that. What we're going to do first is we're going to find what's the proportion of people in the population who would have an IQ that is 130 or greater. So our X score here is 130. Now remember that we're going to have to convert everything to Z. And so Z is X minus mu over sigma. It's one of our formulas we can use. So for this, I always think the first step, this is so important, is to sketch the distribution so that we know what we're looking for. And this is where I see people have lots of problems. So we're going to sketch this normal distribution. We know our mean is up here at 100. And we have to find our z-score. What z-score goes with 130? So Z equals 130 minus 100 divided by 15. Now we know that 130 minus 100 is 30. And 30 divided by 15 is 2. So z-score here is going to equal 2. So we can then draw that on the distribution. So we know z equals 2, and we're trying to find 130 or above. So then we need to look up a z-score of 2 in the table. That's on the second page. And we're not looking from z to the mean. We're trying to find z to infinity. So for z to infinity, we're going to look in that column C, and we find for a z-score of 2, that's 0.0228. So the proportion here is 0.0228. Great. Okay, so that would be our answer for that problem. Now, let's do a very similar problem, but this time our X score is going to be 70 or above. Now, 70 or above, that's an interesting cutoff to use because 70 is typically one of the cutoffs that's used for special education programs. So anyone who would have an IQ of 70 or below might qualify for a special education program. So what we're going to try to see actually is the opposite. What proportion of people in a school system are going to be mainstreamed into a normal classroom? So for this, we're looking for 70 or above. So we're going to have this proportion of the population, or we're going to have this proportion is going to be below the mean, right? We know that it's going to be somewhere down here below because the mean is 100. Okay, so now we have a z-score of 70 minus 100 over 15. We know that 70 minus 100 equals negative 30. Negative 30 over 15 is going to give us negative 2. So negative 2 down here. Okay, my 2's a little wonky. So negative 2. Now, we're not trying to find negative 2 to infinity, right? That would give us the wrong part of the population. What we want to do is find this area to the right of negative 2. Now, that's a little harder. And there are two ways to go about it, right? We know that we just looked up the proportion that goes with a z-score of 2 to infinity. So that would be one way. We've already got this 0.0228 over here. So what we could do with that, remember that the area under the curve always adds up. All the probabilities together add up to 1. So if we're looking for the part that's not, right? If we're looking for the part that is not this part over here, we could just subtract the probability we've already found from 1. So one way to do this problem is 1 minus 0.0228. And we could use that to find the answer. The other way to do this is to divide it into two sections. If the area under the curve is always 1, that means that half of the area under the curve, right, this part here, that's going to always equal 0.5. So then, if we know that that part equals 0.5, our job would be to find the area here. And that's something that we already know how to do too. We can find from z to the mean. So if we look at the table again, we see from z to the mean, so at a z-score of 2, we see that the part of the distribution from 2 to the mean is 0.4772. So we know that this part here is 0.4772. That's its proportion. So then to find the answer, we could just add 0.5 to that, right? We can add 0.5 since it's the other half of the distribution. And in both of these situations, right, in 1 minus or in 0.4 plus, we get 0.9772, right? That's the same thing that we would get up here, 0.9772. So in a problem like this, right, it's a little more complicated and you've got some choices of how you're going to work it out, but it is vital that you sketch the distribution. Without sketching that, you probably would have written down 0.0228 and thought you had the right answer. But we have to make sure that we are thinking about what part of the distribution it is that we're trying to understand. Okay, so let's do another problem. Let me find some extra space down here. For this problem, let's say that we are looking for an IQ score. We're trying to figure out who qualifies at, like, what proportion of the population is going to have an IQ score that doesn't qualify them for any special education. So I said that 70 was our qualifier on the low end. On the upper end, it's actually 130 for a lot of school districts. So if we sketch out our distribution, what we're trying to find here is going to be this area, right? We want to look at the area between these 2 points. And we're trying to find an X score over here of 70 and one over here of 130. Now, I'm using these same numbers because we've already calculated those z-scores, and they're really easy to work with because we know that we know what their values are. So I'm going to go ahead and finish sketching my distribution. I know that on the low end here, right, that z-score, because we just worked it out, corresponds to -2, and on the upper end, it corresponds to 2. So we're trying to figure out what is the area, what is the probability, what is the proportion of individuals who score from -2 to 2. Now, an easy way to figure this out, right, we can see that it's z to the mean, so we just need to find z to the mean for our left side and z to the mean for our right side. Now, we know that they're the same, right? It's symmetrical from -2 to 2, but if it weren't, we would be able to figure these out independently by looking from z to the mean for each of these, and then we would add them together, right? So in some senses, we're subtracting, and in some we're adding, but in both cases, it makes sense once we draw it. Of course, we're adding. We're trying to find this area on the left plus the area on the right. So we'd find our proportion for the area on the left, which we know equals 0.0228. And we'd find our proportion for the area on the right, which we know equals 0.0228. And then we're just going to add those together, right? So we would add 0.0228 and 0.0228. And we would get 0.0456, right? So that would be our proportion of, that cannot, oh, look, I did it. I made the mistake. I went from z to infinity. So it's really easy sometimes, but notice that I got to my answer there. That's sort of embarrassing. I got to my answer there, 0.0456, and I looked back up there and said, look, that's 4% of the distribution. And I could see from my drawing that that was wrong. That's not 4% of the distribution. It should be more like 90-something% of the distribution, right? If I'm trying to figure out that main part of the distribution. So I've got to get rid of this, and let's try again. So I went from z to infinity, even though I knew I needed to go from z to the mean. So if we look from z to the mean here, right, we know that that is 0.4772. And this is going to work out a little better. So from z to the mean is 0.4772. We're going to add that together with the area on the right, which is also 0.4772. And then we're going to get something that's much more reasonable for this. So we get 0.9544. Okay, so I feel much better about that because that's 95% of the distribution that we've got covered up there, not just 4%. So great. So that is like how this works. And you could do this with any proportions of the distribution, but it is vital that you sketch it out so that you can catch your mistakes, so that you can really see what you're doing and understand the parts of the distribution you need to find. And then finally, the last thing I want to do is sort of what's left, and that is to take a portion of the distribution that is on one side together. So let's say that we want to figure out a group of people who qualify for gifted education. So we're going to be looking at 130. And we're going to see like what proportion of the people are between 130 and 145. So 130 to 145. So we already have our z-score for 130. We know that's 2. So let's find z for 145. So z equals 145 minus 100 over 15. I know that 145 minus 100 gives us 45. 45 divided by 15 is 3. So we're trying to figure out what's our proportion between 2 and 3 standard deviations. So for this one, right, we have to figure out what to look at. And there are 2 ways to do it. So I'm going to do it once the first way and then again the second way. The first way to do it is to go z to infinity. So for this one, we're going to go from z to infinity. We're going to do that for 2, and we're going to do that for 3. And so when we do this, when we find z to infinity for both numbers, so we know that z to infinity for 2 is 0.0228. And that really is the right one this time. And then for 3, if we work that out, we get z to infinity, that's 0.0013. So we've got 0.0013, and that corresponds to 3 standard deviations. So in this sense, the from z to infinity for 2, right, that's giving us everything from there on. And from z to infinity for 3 is giving us this part over here. Now, the part in red there, we don't actually want, right? Remember, we're looking for just the part here between 2 and 3. So anything after 3, we don't want. We want to get rid of it. So that means that we are going to actually subtract. So in this case, you can't ever have a negative proportion. So we always want to make sure we're subtracting our smaller number. So 8 minus 3 gives us 5. 1, 2. So the proportion between 2 and 3 standard deviations that has an IQ between 130 and 145 is 0.0215. So a little over 2% of the population. Okay, so that's one way to do it. The second way to do it is really similar, but we can do the exact same thing going from z to the mean. So let me erase my scribbles here. And so for this, what we're going to do is we've got our mean here. And so we can go from 2 to the mean, and we can also go from 3 to the mean. In this case, we're still looking for that shaded area that I did black lines, but we're also going to be getting some extra over here. So we have from 2 to the mean, and then we also have from, so we've got everything from, sorry, let me actually get rid of, let me get rid of these colored lines. I think switching colors on you would be confusing. So, okay, from 2 to the mean will give us this section. I'm going to do it in green. And so 2 to the mean gives us this part. We don't want that part, right? That's not part of what we're interested in. And then from 3 to the mean gives us all of this. So it covers the area we're interested in plus some. And so what we want to do is to get rid of all of this. And we can just do that by subtracting. And so here we're going to go from z to the mean for both of these. And so if we start with our 3, from 3 to the mean gives us 0.4987. So 0.4987. Okay, and then from 2 to the mean, if we look that one up, that gives us 0.4772. So 0.4772. Now we're trying to get rid of an area, so we're going to subtract. So that gives us 5, 1, 2, 0. So 0.0215. So we're going to get the same answer, right? In either way we do it. So both of these are fine. You just have to make sure that you are really sure about what area you need and what you're trying to get. And so whenever you sketch this, the idea is you want to label the actual X scores, right? So if I let me just draw a new version of this so you can see what I'm labeling. So I'm going to draw my distribution. It doesn't have to be beautiful, but I need to label my mean so that I can really see where that is. And then I need to think, okay, the score I'm trying to find, is it above or below the mean, right? So let's say that I'm looking for how many people are between 70 and 90. I'm going to write both of those in there, right? And then I'm going to say, okay, I'm looking for between 70 and 90. So I'm going to go in and shade that area. So now when I find out my z-scores for those, right, I know that 70, my z-score there is going to be -2. I don't know what 90 is, so I'd go and figure it out. I'd be like 90 minus 100 over 15. That's going to be -10 divided by 15. That's what I actually have to do the calculation for. It's going to be 0.67. So this is going to be -0.67. So I know now that I'm looking for the area between -2 and -0.67, and then I can use that sketch to figure out what to do with my table. So in thinking about all of these different versions of this, right, sketching the distribution is a really important step to helping you figure out how to use the table, whether you should be adding or subtracting, what you should be adding or subtracting. So all of this hinges on that drawing. So make sure that you are drawing, that you're labeling your X scores, that you're labeling your Z scores, and that you're shading in the right areas. And that's going to make all the difference in understanding and doing this part correctly. So thanks.